we're looking here at ionic bonding, and this is we're not going to look at properties in this video. We're going to have a look at what actually causes ionic bonding and how to draw it. So an ionic bond is any bond between a metal and non-metal, and it involves the transfer of electrons. So if I give you the most simple example here, sodium is in group 1 of the periodic table, so it has 1 outer electron. Chlorine is in group 7, so it's 1 short of a full outer shell, we'd call it, but it has got 7 outer electrons. You only have to draw the outside shell, you don't have to draw the inside shell. You can get away with drawing the inside shells, but it gets very cluttered, so we tend not to draw them. Now, what that means is that I need a full outer shell or an empty outer shell. I need either 8 in the outer shell or I need 0. This has got 1, this has got 7. So the easiest way to do this is to take the outermost electron on the sodium and put it on the chlorine. So as a result, the chlorine will have 8 electrons and sodium will have none because it's lost it. Now this will get you no marks in the exam because this is not how you draw it. The way you go about drawing it is to draw what we call square brackets around the outside. So each of them would have square brackets, and sodium has lost an electron. Now, because electrons have a negative charge, that means what's left behind is a positive charge. So sodium will be positive. All metals end up positive. Now, because it lost 1 electron, that's a 1 plus charge. Chlorine, on the other hand, which starts off with 7, and normally you do this as crosses and dots. I'm just using different colours because it's easier to see on this. So chlorine, which originally had 7, has gained that extra 1 from the sodium, which means it's now got an extra negative charge. So overall, that would be minus. Now, because it's only 1 extra electron, it's a 1 minus charge. So we don't write the 1s. And that would be giving you 2 marks in an exam. So that's how you would draw it. I'm going to take a slightly more difficult example, and we take calcium chloride, which is probably one of their most favourite compounds to give you exam questions on. Calcium has got 2 outer electrons. Chlorine has got 7, as we've already discussed. Now, as a result, if I want to fill chlorine, all I would do is I'd take one of those electrons and I'd put it on the outside. You might be able to spot the problem because now chlorine's full. Chlorine has 8 outer electrons, but calcium still has 1 more. So what you would do instead is you would get another chlorine atom, and this electron would go onto the chlorine, meaning for every calcium atom, you need 2 chlorine atoms to mean that calcium has no outer electrons and chlorine has 8 outer electrons. But how do we draw that? Well, we do exactly the same thing. And if you're stuck, what I would suggest you do is draw square brackets around the metal, and you put a plus because it's always going to be positive. And then if it's in group 1, it's a 1 plus. If it's in group 2, it's a 2 plus, and calcium is in group 2. So it's a 2 plus because it's lost 2 electrons. If it's in group 3, it's 3 plus. Then on the chlorine, you draw the chlorine as we did before, with 7 outer electrons. And then my extra 1 electron from the metal, just there, and I would put my -1 charge. Now, because the charges need to be balanced, I need 2 chlorines to every 1 calcium. And the way I do that, and this is where you get your last mark for, is I put a big 2 before the chlorine, because the 2 means that you've got 2 chlorine ions to every 1 calcium, and that will mean that's 2 minus balances out the 2 plus.